Close your eyes for a moment and imagine absolute darkness. No stars, no galaxies, no planets. Just silence stretching across an endless void. This was the universe for nearly 100 million years after the Big Bang. A cosmic expanse filled with invisible gas, but no light, no sparkle, no fire. It's almost impossible for us to picture. Every night, when we step outside, the sky greets us with stars, countless pinpricks of light, comforting and eternal. But there was a time when a universe had none of that. No twinkling guides in the darkness. No warmth. Only silence. And then, something extraordinary happened. Out of the silent depths of hydrogen and helium, gravity began pulling matter together. Slowly, patiently, like an artist gathering raw clay. Pressure built, heat rose, and one day, in a place billions of light years from where you sit right now, the very first star was born. In that instant, after eons of pure darkness, the cosmos lit up. It was the first sunrise of the universe. Tonight, we're going to travel back, not just billions, but more than 13 billion years, to witness that dawn. The moment the first stars ignited. We will see how they lived, how they died, and how their brief, brilliant existence changed the universe forever. Because without those first stars, there would be no galaxies, no planets, no oceans, no trees, no skies, and certainly no you or me. This is the story of the first light, the story of the cosmic giants that ended the universe's dark age. Let's set the stage. The Big Bang had already happened. Space itself had stretched and cooled from its fiery birth. By now, the universe was about 100 million years old, still a baby by cosmic standards. But what did it look like? Imagine an ocean of gas stretching endlessly in every direction. Thin, invisible, almost entirely hydrogen, with just a sprinkling of helium. That's it. There were no stars to shine, no galaxies to sparkle. Even though the universe was full, it appeared empty. It was like a theater before the curtain rises. Everything was in place, but the performance hadn't yet begun. Astronomers call this period the cosmic dark ages, not because nothing was happening, but because nothing could be seen. The matter was there, the ingredients were waiting, but the lights were still off. If you had somehow drifted through this young universe, you would have seen nothing, just cold, infinite blackness. Maybe, if your eyes were impossibly sensitive, you'd catch a faint glow from the Big Bang's afterglow, like embers fading in a fire. But otherwise silence, stillness. Yet beneath that quiet surface, forces were at work. Tiny ripples in density, imprinted in the first instant of the Big Bang, were pulling matter together. Hydrogen atoms gathered in slightly denser patches of space. Slowly, inexorably, they began to clump. These ripples would become the seeds of galaxies. The dark ages weren't truly empty. They were pregnant with possibility. It was a universe holding its breath, waiting for the spark, waiting for the first stars. And when that moment finally came, the darkness would never return. So how do you light a star? It all begins with gravity, the universe's patient sculptor. Over millions of years, gravity tugged on vast clouds of hydrogen and helium, gathering them into clumps. Picture a snowball rolling down a hill, gathering more snow as it tumbles. Except here, the snow is invisible gas, and the hill is billions of light years wide. As the clouds compressed, the centers grew denser. Temperatures climbed higher and higher. At first, nothing seemed to change, but inside the heart of those clouds, pressure built until atoms were squeezed so tightly that something extraordinary happened. Hydrogen atoms began fusing into helium. That single reaction, nuclear fusion, released staggering amounts of energy, enough to push back against gravity, enough to make the gas glow. And in that moment, the first star ignited. Imagine it. The universe had been pitch black for over 100 million years. Then, suddenly, a point of light flared into existence. Then another, and another. At first, they were rare, lonely beacons scattered across an ocean of black. But soon, like sparks catching on dry wood, more and more stars lit up. The cosmic stage had its first fire. This was the dawn of starlight, the end of the Dark Ages, the beginning of a universe that would one day blaze with billions upon billions of suns. For the first time, the cosmos could see itself. But these stars, they weren't ordinary. They weren't like the ones twinkling in our sky today. They were something else, something extraordinary. Astronomers call these pioneers' population 3 stars. A technical name, yes, but what it really means is simple. They were the first, the original generation, and they were titans. Our sun, steady and warm, is average, about 1 solar mass. But these ancient giants? They could be 100, 200, even 300 times more massive than the sun. With great mass came great power. They burned hotter, brighter, and bluer than almost any star we see today. Their light was fierce, their radiation intense enough to transform the very fabric of the universe. But that brilliance came at a cost. While our sun will live for about 10 billion years, these giants survived only a few million. A blink of an eye in cosmic time. They were fireworks, brilliant, explosive, and fleeting. Another difference? Their purity. Modern stars, like our sun, contain metals. In astronomy, that means anything heavier than hydrogen and helium, carbon, oxygen, nitrogen, iron, all born from earlier generations of stars. But the first stars had none of that. They were made almost entirely of hydrogen and helium, the elements created by the Big Bang. Without heavier atoms to cool the gas and fragment it, the early universe gave birth to enormous stars. Simpler chemistry, simpler building blocks. If our sun is a candle glowing steadily in the night, these first stars were roaring bonfires, consuming themselves furiously, blazing with a light that reshaped everything. They didn't just shine for themselves. They were trailblazers, cosmic pioneers, because in their short but brilliant lives, they prepared the way for everything that followed. Every life ends, even the lives of stars. For these giants, their deaths were as spectacular as their lives. When their cores ran out of fuel, gravity once again seized control. Their massive hearts collapsed inward, and in a fraction of a second, they exploded. Supernovae, blasts so powerful they could outshine entire galaxies. In those final moments, temperatures soared high enough to forge entirely new elements. Carbon, oxygen, silicon, iron, the very stuff of planets, oceans, and life itself. The first stars didn't just shine. They cooked. They were cosmic forges, creating the raw ingredients of existence. And when they exploded, they scattered those elements across space. Think of a chef tossing spices into a soup. The universe was that soup. The first stars were the chefs. Without their explosive deaths, the cosmos would have remained bland. Just hydrogen and helium. No rocky planets. No blue skies. No living cells. So yes, their deaths were tragic, but they were also beautiful, because in their destruction, they planted the seeds of creation. And from those seeds, everything else would one day grow. The first stars did more than just shine. They transformed the universe. Their intense radiation began stripping electrons from hydrogen atoms in the surrounding gas. Astronomers call this process reionization. In simpler terms, their light cleared the fog. Imagine standing in a thick mist where everything is hazy and hidden. Then, as the sun rises, the fog begins to burn away. Suddenly, the world appears sharp and clear. That's what the first stars did. They lifted the cosmic fog. The universe, once murky and opaque, became transparent. For the first time, light could travel freely. Galaxies could form clearly. Cosmic structures blossomed into view. This was the true dawn, when the universe became the bright, structured place we know today. From that moment forward, darkness would never again rule the cosmos. The stars had won. Here's the twist. We've never actually seen a population 3-star. Why? Because they lived fast and died young, more than 13 billion years ago. None survived to the present day. But astronomers are detectives. And the universe, even in silence, leaves clues. They search for fingerprints of these ancient giants in the oldest galaxies. They study faint patterns of light, chemical signatures that whisper of stars long gone. And with new tools, like the James Webb Space Telescope, we're closer than ever. Webb has already peered deeper into time than any telescope before it, spotting galaxies that existed just a few 100 million years after the Big Bang. Someday soon, we may glimpse their legacy, perhaps in the strange glow of an early galaxy, perhaps in the elemental makeup of ancient gas clouds. Their light may finally reach us, across billions of years, like whispers from the dawn of time. Now comes the part where the story turns personal, because this isn't just about distant stars long gone. This is about us. Every atom in your body has a history. The calcium in your bones, the iron in your blood, the oxygen in your lungs. None of it came from the Big Bang. None of it existed in those early dark ages. It all came from stars. From the very first generation that forged the first heavy elements to the countless generations that followed, every breath you take is a gift from stars that lived and died long before Earth was born. Carl Sagan once said, "We're made of star stuff." And he was right. The iron in your blood was born in the fiery death of a star. The oxygen you breathe was forged in stellar cores. The carbon that makes up your cells, your DNA, your thoughts, all of it, stardust. Those first stars may be gone. Their light extinguished billions of years ago. But their story lives on, in you, in me, in every living thing. So the next time you look up at the night sky, remember, the light you see is just the latest chapter in a story that began with those first cosmic giants. We are, in the deepest sense, children of starlight. And so, the darkness ended. The first stars lit the universe. They lived brief, brilliant lives. And in their fiery deaths, they seeded the cosmos with the elements of creation. They didn't just shine. They set the stage for everything that followed. But the story doesn't end here. Because those first stars passed the torch. They gave rise to new generations, stars that would take those raw ingredients and forge them into the full recipe for life. That is the story of stellar alchemy. So join me in the next episode, where we'll witness how stars became cosmic forges, transforming the universe into a place where life could one day emerge. The first stars ended the darkness. The next would write the recipe for life.